Okay, this is another example of a hypothesis test. The mean systolic blood pressure for males 35 to 44 years of age is 128, and the standard deviation in this population is 15. The medical director of a company looks at the medical records of 72 company executives in this age group and finds that the mean systolic blood pressure in this sample is X bar equals 126.07. At the level of alpha equals 0.05, is this evidence that executive blood pressures differ from the national average? So, to do the hypothesis test, to answer this question, we need to know what our null and alternative hypotheses are, right? So it says that the mean systolic blood pressure for males 35 to 44 years of age is 128. And the question is asking, is there evidence that executive blood pressures differ from the national average? That is, the blood pressures of executives, right? The medical director was looking at the records of 72 executives, and their mean was 126.07. So the null hypothesis, right? To figure out what the null and alternative hypotheses are, you have to ask yourself, what is the thing that we want to know about? And what we want to know about is the average blood pressure of executives. So first, let's make mu the average blood pressure of all company executives, and it's actually company executives, not all company executives, it says in this age group. So in the age group, and these are males 35 to 44 years of age. So all company executives who are male and 35 to 44 years old. So that's the number that we're interested in. The average blood pressure of all company executives who are male and 35 to 44 years old. And so for the null hypothesis, so we're asking whether executive blood pressures differ from the national average. So the running assumption, the null hypothesis, is that there is no difference. So, well, it says the mean systolic blood pressure for men 35 to 44 years old is 128. Right? It says right there. So the null hypothesis is that mu is 128. Okay, what's the alternative hypothesis? Well, it's asking whether there's evidence that executive blood pressures differ from the national average. So in other words, it's not equal to the national average, which is 128. Okay, so those are the hypotheses. Now we have to see how much evidence there is from the sample in favor of the alternative hypothesis. So there's a sample of 72 blood pressures, and the mean is 126.07. So the z-value is going to be our x bar, our sample mean, minus mu divided by sigma over square root of n. So that's going to be 126.07 minus 128, right? Because we're assuming that the null hypothesis is true, which is that mu is 128. And then divided by sigma, okay, where is it? Oh yeah, it's 15, because it says the standard deviation in this population is 15. Okay, so that's Well, it actually says that 15 is the standard deviation of the